Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So to solve this, I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now, I'm going to rewrite x to the power of 6 as x to the power of 3 to the power of 2. So I have x to the power of 3 to the power of 2 minus x to the power of 3 minus 2 is equal to 0. Now, if I let x to the power of 3 equal to the variable y, I'm going to have y to the power of 2 plus y minus 2 is equal to 0. Or sorry, y to the power of 3, or sorry, y to the power of 2 minus y minus 2 is equal to 0. And if I factor this, I get y minus 2 times y plus 1 is equal to 0. So this gives me two equations. I have y minus 2 is equal to 0, and I have y plus 1 is equal to 0. So for y minus 2 equals 0, y is equal to 2, and for y plus 1 equals 0, y equals negative 1. So now remember how we set y equal to x to the power of 3. So if y equals 2, then we have 2 is equal to x to the power of 3, meaning x is simply equal to, I'm going to take the cube root on both sides, x is equal to the cube root of 2. So this is one solution of x. Now, if y is equal to negative 1, then I have x to the power of 3 is equal to negative 1. So now to solve this, I'm going to add 1 on both sides. So I get x to the power of 3 plus 1 is equal to 0. Now, x to the power of 3 plus 1, I can rewrite that as x plus 1 times x squared minus x plus 1 is equal to 0. So this gives me two equations. I have x plus 1 equals 0, which is simply means x is equal to negative 1, which is one solution. And I have x squared minus x plus 1 equals 0. And to solve this, I actually have to plug this in the quadratic formula, and I'm not going to waste your time doing all of that, but the two solutions I get of x are, I get x is equal to 1 plus or minus the square root of 3i over 2. So these are my four solutions to this problem. Alright, so in this problem, I have 2 to the power of 3x plus 2 to the power of x is equal to 10. So if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 3x, we can rewrite that as 2 to the power of x to the power of 3. So I have this plus 2 to the power of x is equal to 10. Now, I'm going to go ahead and let the variable y equal to 2 to the power of x. So if I replace y with 2 to the, if I replace 2 to the power of x with y, I get y to the power of 3 plus y is equal to 10. Now if I subtract 10 on both sides, I get y to the power of 3 plus y minus 10 is equal to 0. Now all we have to simply do is factor this. And y here, I'm going to rewrite as 5y minus 4y. So I have y to the power of 3 plus 5y minus 4y minus 10 is equal to 0. Now I'm going to factor this in groups. I'm going to factor y to the power of 3 plus 5y and also negative 4y minus 10. So for y to the power of 3 plus 5y, the greatest common factor is y. So I get y times y squared plus 5. And for negative 4y minus 10, the greatest common factor is negative 2. So I have negative 2 times negative 2y plus 5. Sorry, times 2y plus 5. And this is equal to 0. Or, sorry, actually, instead of doing that, what I'm going to do is I'm going to rewrite this as y to the power of 3 minus 4y plus 5y minus 10 is equal to 0. So I simply just switch these two places. And now if I factor this, I get y times y squared minus 4 plus 5 times y minus 2 is equal to 0. Now y squared minus 4, that's the same thing as y plus 2 times y minus 2. So I have y times y plus 2 times y minus 2 plus 5 times y minus 2 is equal to 0. Now if I factor out y minus 2, I get y minus 2 times y squared plus 2y plus 5, and this is equal to 0. So now this gives me two equations. I get y minus 2 equals 0, which means that y equals 2. And I get y squared plus 2y plus 5 is equal to 0. And to solve that, we'd actually have to use the quadratic formula. So let me go over here. I have y squared plus 2y plus 5 is equal to 0. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, this would be, b is 2, so I have negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is 5. And if you notice, actually, 4 minus 4 times 1 times 5 is the same thing as the square root of 4 minus 20, which is equal to the square root of negative 16. And you can't actually take the square root of a negative number, meaning this is wrong. And alright, so for this problem, I have 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And I have 4 answer choices. So I want to figure out which answer choice is the correct one for this problem. So how I'm going to do that is I'm going to go one by one with each answer choice, and I'm going to figure out which one is the correct one. So my first answer choice here is 27 to the power of 30. How you get this is you first start by adding all the bases. So you do 9 plus 9 plus 9, and then you also add all the exponents. So you do 10 plus 10 plus 10. Now 9 plus 9 plus 9, that's 27. And 10 plus 10 plus 10, that's 30. So you get 27 to the power of 30. And this is actually the wrong way of doing it, because you can't add the bases and exponents like that. That's the wrong way. So now the next answer choice is 9 to the power of 30. And to get this, what you're going to do is you're going to keep the base the same, so you don't do anything with the base, and then you just add all the exponents. So you do 9 to the power of 10 plus 10 plus 10. And this is equal to 9 to the power of 30. And this is wrong as well. That's not the right way of adding exponents. So now for C, we have 9 plus 9 plus 9 to the power of 10. So you just add all the bases this time and keep the exponent the same. And this gets 27 to the power of 10, and this is the wrong method as well. So finally, I have 3 to the power of 21. And how I do this is I first start with 9 to the power of 10 plus 9 to the power of 10 plus 9 to the power of 10. And now I'm going to replace 9 with, I'm going to factor out 9 to the power of 10 from this. So I get 9 to the power of 10 times 1 plus 1 plus 1. Now, 1 plus 1 plus 1, that's 3, so I get 9 to the power of 10 times 3. Now, 9, that's the same thing as 3 to the power of 2, so I have 3 to the power of 2 to the power of 10 times 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of 10, that's going to equal 3 to the power of 20. And I have this times 3 to the power of 1. Now, I have a to the power of m times a to the power of n. This is equal to a to the power of m plus n. So 3 to the power of 20 times 3 to the power of 1, that's going to equal 3 to the power of 20 plus 1, which is equal to 3 to the power of 21. So this is the right answer.